Hello, my name is Martin, and today I will be talking to you about the iterator pattern. So let's start with the basics. Let's talk about the category where this pattern belongs. First, it falls under the behavioral category, where such patterns are responsible for identifying communication links between objects and their classes. And of course, the use of such patterns will increases the flexibility of a project, which results with an overall loosely coupled design, which is indeed a good feature to have on a project. So, what is an iterator pattern? The formal definition says that it provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. So, what does this exactly mean? By using the iterator pattern, the user is able to step through the elements of an aggregate without having to know how things are represented under the covers. So basically, the users can access multiple data structures without really needing to understand how they are working or how they are implemented. Additionally, these patterns takes the responsibility of traversing elements and gives the responsibility to the iterator object, which ensures simpler interfaces and simpler implementations, so less work from the user and more work on the machine side. So we get an overall result of a cleaner project, a cleaner code, easier to understand and easier to implement. So let's see a practical example to understand better the iterator pattern. The very first thing it's good to point out is that what is an aggregate object? We can think of an aggregate object such as a list or an array, a data structure that is capable of holding some sort of data and being able to give it meaning. Of course, the user can access, traverse, modify, update. All sorts of functions are possible with this sort of aggregate object that you have. And all this is done without the necessity of exposing the internal structure of the list. For example, whenever we access an array, element 5, we are only simply interested in accessing the element. We are not interested in knowing how to access it. And the iterator patterns allows the user to perform all sorts of operations on a determined object by taking the responsibilities out of the object, which are access, traversal, and puts those responsibilities inside of the iterator object. So the applicability of it. So where is this applied? Well, the iterator pattern is used to access an aggregate object, as we've been saying, its content without exposing its internal representation. It supports multiple traversals of aggregate objects, which simply means that it's not only one object that we can access, but it could be a multitude of objects that are completely different from one another. Also, it provides a uniform interface for traversing different aggregate structures. It supports polymorphic iteration. This simply means that no matter the amount of objects we have, they all are going to have one single interface which we access them from. And this is what makes the iterator such a powerful pattern and also good to implement in a project that is able to take multiple things and able to use the same interface so as to be able to access different functions from different aggregate objects. So this is the basic structure of the iterator pattern. In here we have a client that is able to connect the aggregator and the iterator pattern and the iterator class. In the iterator class we're going to have simple functions such as first, next, is done, or current item. These functions will help us determine where we are in the list or in the area, and it's pretty much they help the iterator pattern to determine if there is another element or if there are no more elements, if we're at the end of the list or if we're at the beginning or in the middle. The aggregate class, in here we will have a method that will create the iterator. From here we have the concrete aggregator, which will implement the abstract aggregator, and in here we are going to create the actual iterator. And the same thing goes for the concrete iterator as well. He extends from the abstract class of the iterator, and we're going to create the concrete iterator by inheriting all of the different methods that we see. So what are the participants again? So just to mention and have a slightly better definition, the iterator, which defines the interface for accessing and traversing the elements. The concrete iterator, which implements the iterator interface and keeps tracks of the current position of the iteration. The aggregate defines the interface for creating an iterator object. And the concrete aggregate implements the iterator, creating an interface to return an instance of the proper concrete iterator. So, what are some known uses for this pattern? Where is this pattern used in the real world? Well, they are very common, especially in object-oriented systems, and very popular in the collection class libraries, and they offer some sort of iterator in one form or another. So we've been talking about aggregate objects, and now we're talking about collection. Just to give you a better understanding of what we're talking about, a collection libraries, for example, is simply implementation of behaviors that are written in terms of a language that has a well-defined interface by which the behavior is invoked by multiple programs that might have no connection to each other. So to make it simple, you can think of a collection as a bunch of functions that can be implemented by external programs. And here we have a little diagram that kind of shows the structure of a collection and the hierarchy that goes with it. Some related patterns to the iterator is the composite pattern, which is applied to recursive structure, the factory method, which polymorphic iterators rely on factory methods to instantiate the appropriate iterator subclass, and finally the memento pattern. Such pattern can use a memento to capture the state of an iteration. So now to my idea, to the project that I decided where I implemented the iterator pattern. And the basic idea is we will have two different shoe stores that will contain different types of shoes, and in here the shoes represents the product. Each shoe will have a name, a color, a release year, and a price, and these are the different attributes that come with the product. Now, as I mentioned earlier, we'll have two stores. We'll have the Nike store, which will be implemented by using an array list, and in the array list we'll have the different shoes, and we'll have the Adidas store, which will be implemented by using a fixed size array. Both stores will have iterators that will allow a clerk, which is the client, to display all of the present products in both stores, and of course we will have a simulator which will implement all of the above features. This is the implementation of the UML. As we see, the structure very well represents the same structure, the structure of the iterator patterns. In here we have a client, which is defined by the clerk class, where we define the two different types of stores, and also of course we have the constructor for the clerk and the different functions. We have the two interfaces, one for the store, one for the iterator, and from both the interfaces we have the concrete classes, where we implement the Nike store, the two stores, and of course the two iterators for the two stores. In addition, we will have a store product, which is a class that defines our product, our shoe, and such class will have the very basics: a string, the name, the color, the price, the release, and the getters for this method. This class is necessary in order for us to be able to implement this pattern. and finally the demo. And this is the program I was talking about. This is the class structure, and this is the iterator pattern, which I'm showing you guys. So let's start with the store product, the very basic class. In here, this is the concrete product, and in here we have all the attributes that define the product. And the product in this case is a shoe. Each shoe will have a name, will have a color, release year, price, and so forth. In the construction, we will ensure that we pass all of the different attributes, and of course the getters and setters. The getters, no setters. This is the interface store, which will simply have the create iterator method. This is the iterator interface, and the iterator interface will implement the has next boolean function, and of course it will have a store product type of next, and this will simply return the next element in the list. These methods will be both used by the two concrete iterator classes. So let's start with the first one, the Nike iterator. In here we implement the interface, the iterator for the interface. The very first thing we do is we define an array list where we're going to store the different products. The count will help us determine the position in the array list, and this is why it has been and that is why it's been set to 0. So that is our starting position, the first element. The constructor determines the object that the iteration will happen over. As you see, the iteration will happen over this specific product, which is indeed the shoe. The next thing we do is we will return the next item in the list through this function we'll be able to return the iterator will be able to move from one position to the other by using the count and the next function. Also, the hasNext checks if we've seen all products in the list. So the next one will return the next item, and hasNext will check if we've checked all of the products. Same thing with the Adidas iterator, the second store. In here, the only difference relies in the declaration of the array. In here, instead of using, as we use in here, an array list, in here we are going to use a common array, a normal array, a fixed size array. And same thing as in the previous store. The object we need the constructor where we will pass the object where we will store all of our products. And of course we inherit the two methods from the interface, hasNext and next, and they do the same exact thing that they were doing in the other store. They check whether the array is full or no, and they return the next element in the array. So now let's go to the stores. These are the concrete stores, and each store of course has its own implementation. By implementation I mean its own aggregate object. And the constructor the different products are added in the constructor. As you see, we already have one product in there. This is the first product. Also we have a add products function, which will take all of the different attributes like name, color, price in here, and we'll be able to create a new product, and we'll be able to add that product for us. So this will help the constructor. This function will be called in the constructor, and it will add these elements to the array. And finally, we have the iterator, which is an iterator type, and it will return the current objects, the object where we are holding all of the different products. And it creates a Nike iterator from the store products, returns it to the client. The client does not need to know the implementation of the Nike store or the iterator. It just needs the iterator to step through the different elements in the array list. So this is the meat of the program. This is of the pattern. This is its basic duty to be able to return and step over the different products, the different elements, and return something to the client. The same thing in the Adidas store. We will have a fixed array. We will create a new element inside of the constructor, and we'll be able to add things to the constructor by simply calling this add product function, which will help us add the products. Now, the one thing I've decided to do in here, since we're using an array, I have decided to set a fixed size, and of course the fixed size is going to be, I believe it to be 2. So if we add more than 2 elements, we should get an error. And the same thing in here, the iterator is created, and the iterator will be able to return this product to the client. Finally, we have the clerk, and in here the clerk is able to create 2 stores. In the constructor we pass both of the 2 stores. We have a print function. The print function, this method creates 2 iterators, one from each store, and calls the overloaded print method with each iterator. As you see, we have a public void print and a private void print. This simply overloads these methods, and this method will step through all of the different elements and will be able to print all of the different elements. And finally, the simulator. In the simulator, we are able to create the 2 stores, and we are able to call the clerk. We're able to pass the 2 stores, the 2 concrete stores, and of course we're going to call the print function. So just to run it real quickly, we're gonna see that taking some time. Okay, so we see the Adidas store. We have the Adidas Run 1, yellow, year 2017, 200, and in the Nike store we have the Nike Roshi Run, red, year 2018, 100. So if we go back in the Nike store and we add another product, and then we go ahead and run it, as you see now we'll have 2 shoes on the Nike store. Same thing with the Adidas store. If we add another shoe, we will have a second shoe in the Adidas store. And now, as we said earlier, the Adidas store has a fixed size array, and we said that the fixed number was 2. So if we add a third shoe, we should get a system error, and of course we will. As you see, we have the 2 shoes, but also we have an error that says limit has been reached. So thank you very much for listening. I hope I made it as clear as possible. Thank you again. Bye bye.